So here we have two type of the motions. One we have first we have horizontal motion. And the second we have vertical motion. In case of horizontal motion, it will refers to the ocean currents. And it will also refers to the waves. Waves are nothing but the horizontal motion of the ocean. And in case of the vertical motion, we have tides. These are the two types of the motion in the ocean water we have. So waves are the actual energy which move across the ocean surface. Moves across the ocean surface. And water particles will travel. Water particles will travel in small circle as the wave pass. So wind is following in this direction. So it will raise up the water. So when wind is following in this direction, so there is a frictional drag. So it will pull that water up, and now because of gravity, it will fall down. And this is in case of wind following in this direction. So it will fall down. First it will raise up because of the direction of the wind, and now because of the gravity it will fall down. So when it will fall down, now again it will wind is still moving, so it will again rise up. It will form circular motion. So it will create the ripples. These are the ripples. Now the source of energy of the winds. So wind provide the energy. Wind provides the energy to the waves. and wind causes waves to travel in the oceans, and energy is released on the shorelines. So as the waves will move, so it will move in this direction, then again because of gravity it will fall, again it will rise, and then again it will fall. And now because of the gravity, this will fall because of gravity, and this will rise because of the direction of the wind. And when it will form, they will flow in the circular motion. So now the new wave will form. So when this will create, so the next wave which will form, it will form like this. This will collect, and then this will rise here. Similarly, the water here will sink and then it will rise. So this is the new wave, and this is our old wave. So the upper part is known as this part, and this part is known as the crust, and the lower part is known as the trough. So here the trough will rise, and in these areas, in this area, the crust is falling. Similarly, here the crust is falling. And the distance between the one crust to the another crust, that is the distance from here to here, is known as the wavelength. So this is the movement of the waves. So the motion of the surface water seldom affect the stagnant deep water. This is the direction of the waves will form, and here we have our sea, and below this deep water will start. It is around 3,000 to 300 to 500 meters. We have surface water. Now how a coastline will affect the moment. This is our surface water. Then we have the continental slope, and below this we have a deep water. So if a person is standing, so here we have beach. Now the motion will be in the circular form. So when here the waves will form. So they will form in a circular motion. As it moves toward the shoreline, there is no friction is created, and when it will reach towards the beach, so here this shoreline will create a friction. Here friction will create it. Now there is a friction between the dynamic water and the sea floor. So as when it will reach towards the sea floor, here we have no friction. So here friction will be created, so it will slow down the movement. It will slow down the movement. And when the depth of the water is less than half of the wavelength of a surface, the wave breaks. So how does a wave break? These are how waves are moving. And here this will move in the form of ripples. So the distance between two crusts is known as the wavelength. And this is the depth. So if the depth is greater than half of the wavelength, so half of the wavelength will be, this part is half of the wavelength. So when the depth is greater than the half of the wavelength, the velocity is maximum. And when the depth is less than half of the wavelength, velocity will decrease. Here we have half of wavelength till here and the depth till here. So in this case we have depth is less than the half of the wavelength, so velocity will decrease here. That is, here we have water. And when the depth is less than the half of the wavelength, so here we have the surf zone. So this is known as the surf zone. So if a wave is in this direction, this is the trough, this is crust, this distance is the amplitude. So wave amplitude is the half of the wave height. Our earth, here we have moon, so because of the gravitational attraction of the moon, a bubbles will be created. This is tidal bulge. And to balance that gravitational pull, there we have the centrifugal force, which will balance the gravitational pull. So here we have this is this is the bulge of water. Because of the gravitational force. And now when the gravitational there is centripetal force, here we have the centripetal force, centrifugal force, and here we have gravitational pull of moon. So it will create a bulge on the both the side. So here we have two bulbs. Two bulbs of water. So together the gravitational pull and the centrifugal force are responsible for creating the two Second, we have the diurnal tide. There is only one high tide and one low tide diurnal each day. So in this case, it is semi-diurnal tide. We have two high tide and two low tide. Next one is the diurnal tide. In this we have one high tide and one low tide. Here we have low tide and here we have high tide. So this is diurnal tide and semi-diurnal tide. Next we have mixed tide. A tide having the variation in the height are known as the mixed tide. This tide generally occurs along the west coast of the North America and many of the islands in the Pacific Ocean. So in case of the mixed tide, the height will vary. Like this. Here we have high tide, here we have low tide, here we have low tide. So there is a variation of the height. This is mixed tide. These are the three types of the tides based on their frequency. So in case of the mixed tide, a mixed tidal cycle is a cycle having the two high and the low tides of the different size each day, and the difference in the height between the successive height or the low tides is known as the diurnal inequality. So it is known as the diurnal inequality. So the areas having this type of the side along the west coast of the USA. And another is during the new moon period. So in case of spring tides, it will form when Earth, Moon and Sun will be all in straight line. Our Earth we have Sun, we have Moon. So one case will be this, and the second case will be when we have full moon, then we have Earth, and we have Sun. These are the two possibility of having the Earth, Moon and the Sun in a straight line. So in this case we have new moon. This is our new moon and this is our full moon. That is the Purnima and here we have Amavasya. So in the first case, when the earth, moon and the sun are in a straight line, so the bulge towards the moon will be much more than the sun. So the tide will be like this. Here we have the moon's gravitational pull, attraction, and the sun's also. So in this case, earth will create a bulge created toward the moon and the sun, and a counter force will be exerted as a centrifugal force. So these tides will form, that is here high tide, low tide, low tide and high tide. So these are formed. Tidal is directly related to the location of the sun and the moon with respect to the earth. The tide will be higher when the sun, moon and the earth all in the straight line, and the spring tides happen twice a month. These two formula have twice a month. That is during the full moon and the new moon. And once during once during the full moon and again during the new moon. One in case of the new moon and second in case of full moon. And second we have the nip tides. So nip tides are the solar tidal force partially cancel the moon's gravitational force. So in this case we have their sun and the earth and the moon are perpendicular to each other. So the moon's attraction is more than the sun's, and the centrifugal force of the sun's centrifugal force of the sun's gravitational pull weakens up. So the tide will occur at a certain times in the lunar cycle when the range of the tides is at the smallest, and the spring and the nip tides are separated by 7 days in the most of the cases. So in case of the nip tide, we also have the two cases. First quarter of the moon, then we have earth, then we have sun. Similarly in the second case we have third quarter moon, we have third quarter moon, Moon's tidal force is more than the sun, so tide will be created here. And similarly, in the third quarter of the moon, a tide will be created here. And since the sun's gravitational attraction is less than the moon, since moon is much closer to the earth, so here we have the less tidal. So we have this tides will form like having the much more tides bulges towards the moon. Then we have the slighter bulges towards the sun. Then we have more bulges toward the moon than the sun. Earth and moon, when the distance between them is very less than when they are nearest, this is point known as the perigee point. And when they are far from each other, this is known as the apogee. Here the distance between the earth and the moon is when the maximum distance between the earth and the moon, when they have maximum distance. So in these two cases, when the earth is close to the moon, so the height will be much more. In case of the perigee, the height of tide is more because the moon's gravitational pull is much more. So it is once a month when the moon's orbit is closest to the earth. So it will be once a month. And similarly, when the earth is having the maximum distance from the moon, so the height of the tide will be less. So when the moon is far from the earth, that is the apogee, the moon's gravitational force is limited and the tidal ranges are less than the average height.